Hello students, few important points of this chapter were left, so I thought I will complete it today. As I was telling you in my previous sessions that metalloids are located between metals and non-metals, so let us have a look in the periodic table. I had told you previously also that whenever I start this chapter, you should keep the periodic table open. So please open the periodic table in front of you. Now you see, as shown in the slide, that 1A and 2A, this rectangle is called S block, and the block of transition elements from 3B to 2B, which is in blue color, from period 4 to 7, that is called D block, and the all A atoms and inert gases, they are called P block. So S block is on left of transition elements, P block is on right of transition elements, and the lanthanide and actinide series which are shown below the periodic table, that is called F block. So we have 4 block. S block is of group 1 and group 2, D block of transition element, and from group 13 to 18 are all A's and inert gases, they form P block. So this you should know. Then now let us try to see where are my metalloids. Metalloids are shown by this red diagonals. In the second period, boron is a metalloid. In the third period, silicon is a metalloid. In the fourth period, germanium and arsenic is a metalloid. And in the fifth period, antimony and tellurium is a metalloid. In the sixth period, polonium is a metalloid. Towards the left, we have metals. So lithium, beryllium, you know, is a metal. Silicon is a metalloid. So aluminium, magnesium, sodium are metal, and towards the right are non-metals. So phosphorus, sulfur, chlorine is a non-metal, argon is a inert gas. Similarly, boron is a metalloid, carbon, nitrogen, oxygen and fluorine are non-metals, neon is a inert gas. Same thing applies to below. So you will observe that in group 4 and 5 there are 2 metalloids, but in other groups there are 1. And non-metalloids are shifting towards the right, like boron is a metalloid. Next metalloid is in the next period to the right of it, means silicon. Next is below it and towards the right. Next is below it and towards the right, and next is below it. So this is how you can learn. So these are the metalloids as shown in the periodic table. So you see that majority are metals, and even lanthanide and actinide series are also metals. Saying, now let us try to see how to do electronic configuration. You keep the periodic table very handy. It will be required quite often. We have to learn to make electronic configuration up to 30. I had explained you in one of my sessions that what I learnt in 9th standard how to fill up. Now I will tell you other method where we will also come to know that in which orbits the electrons are going. So the easier way to learn is that you write in rough 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. Like first period has only S, second period has S and P, then third has 3S, 3P, 3D, then 4S, 4D, 4F. So you just write this in rough. Okay. So after writing it rough, we have to start from here. So we have to start from here. So first orbit will get filled up. So in first orbit, how many it can have? 2. So we write in this manner 1s2. 1 denotes orbit number. So first orbit I can have maximum 2. So we write s2. Then in the second, after the first orbit got filled up, look at the periodic table. After hydrogen and helium has filled up, now third electron comes, it will become lithium and beryllium. So next will come 2s2. Then after this also get filled up, then in the second orbit p orbits will get filled up. So we'll say 2p6. So look at the periodic table. I told you that this is the p block. Now without understanding how I can write, you start from here 1s2. We make lines from here 1s2. Then make a line parallel so that it should pass through the next element. So then will be 2s2. Then make another line parallel. So it will be 2p6, because in p or block we have got 6 elements. Then 3s2. S has got, remember, S has got 2, P has got 6, and D has got 10 transition elements, and F is 14. So this number, it is increasing by 2. It is increasing by 2. S is 2, P is 6, 4 more, D is 10, 4 more, F is 14. So these you should learn. S is 2, P is 6, D is 10, F is 14. So now after 2p6 I am getting 3s2. After getting 3s2 it will be like this. So 3p6 4s2. Then after 4s2 I am getting like this. So it will be 3d10, D is 10, and then 4p6. But up to 30 I require only up to here. So in this manner you can write this without thinking. But now let us try to see scientifically. So first orbit has got maximum 2. So this is my first orbit 1. 2 means second orbit, maximum 8. 3 means I should have 8, because last orbit cannot have more than 8 that we have studied. So this is 3 is 8. Then fourth gets filled up to second, and then I know after fourth orbit gets filled by second, my third orbit will take 10. So 3d10. So this you should remember, or you can write by looking at the periodic table or from memory. First orbit 2, second orbit S and P, third orbit S and P, then fourth orbit S, and then D will come, or as I told you that you can fill in this manner. Once this is filled, we can make, I have explained you how to make electronic configuration. Now if there is only in whichever orbit, in S I have got 1 electron, so we show it in this manner. We make a rectangle and show this 1 electron. If there are 2, then we show in this manner, 1 up, 1 down. So this indicates that one is moving clockwise, other is moving anti-clockwise. So S1 is shown in this manner, S2 is shown in this manner. Then typically I have shown P4. In P4, so there will be 3 these small rectangles. This rectangle for P orbit and 2 lines, so that 2, 4, 6. Because P orbit I can have maximum 6. So I have shown P4. So first electron will come here, second will come here, third will go in the third, then fourth will come in this first. So this is how we represent P4. Then D4. D4 there are how many? 10. So 1, 2, 3, 4, 5. So 5. So this rectangle orbit is divided into 5 parts. This is first electron, second electron, third electron, fourth electron, fifth electron, sixth will come here in the opposite direction, seventh will come here, 8th, 9th, 10th. This is how electrons fills the various orbits. Is it alright? I will give you 2 minutes, you can revise, and you should be able to make this very fast so that we will not waste much time. First orbit 2, so 1s2, second orbit 8, 2s2, 2p6, then third orbit also 3s2, 3p6, 4s2 and then 3d10. So for the time being up to 10 standards you have to learn only this. Then we will learn how to fill further. Okay, now let us fill the up to 30 elements that is in the syllabus. Hydrogen atomic number is 1, so only 1 electron, so only S1. So I will write 1 S1. The number of electrons are written on the as a superfix. Okay, so 1 S1. Then 2. So orbit is 1 only. So 1 S and it is 2. My first orbit can have maximum 2, so 1 S2. Then lithium, first orbit will get filled up. So 1 S2 and next will go in second S. So it will be 2 S1. In this manner we have to fill. Beryllium, so first orbit will get filled up 1 S2 and then remaining left are 2. So it will go in second orbit 2 S2. Now comes boron. Boron has got 5. So this is up to 4. So up to 4 I can write 1 S2, 2 S2. Now S cannot have more than 5. So as you can see, then I have to go to the pth orbit of second. So it will be 2 P1. Then carbon, in the same manner it will become 2P2. So it will be 1 S2, 2 S2 4, then 2P2. So 6 electrons. So this 7, this will become 2P3. This will become same. And last neon would be 1 S2, 2 S2 4. Then second orbit I can have more 2p6. You can have a look from here. Yes, then it is 2p6. So first 10 I have filled up. So this is how electronic configuration can be written. Is it all right? So now we go to sodium 11. So 11 means this 10 will come. So I will not write all this 10 again. All this 10 will come here. And then after this 10, I am having 3s2. So here will come 3, means third orbit S1. Look at periodic table. 3s1. Magnesium, all 10 would be there. 3s2. So now this orbit has also got filled up. Now my p orbit will come. So aluminum would be 3s2, 3p1. Isn't it? P can go up to 6. So here all this you should write. Then silicon 3p2, phosphorus in this manner. And then what would be potassium? 19. So first we will write 10. This are my 10. Then I have to write 9. So 9 guess I will get 2 and 6, 8. And 1 would be from here. So here this is 10. And then I will get 3s2, 3p6 and 4p1. Sorry, 4s1. Isn't it? 4s1 ऐसा था ना. So 4s1. So this is how sodium, calcium would be same 4s2. Now my 10 are over. Now comes important thing. So up to 20 it's very simple. Now we are coming to 21. This is my 21 scandium. So up to 20 I have to write in this manner. See 2 to 4, 6, 10, 12, 18 and this up to here is 20. Now this 20 will always repeat. But now I want how many? I want 21. So you look here. After 4s2, now third orbit is getting filled up. You can look at the periodic table. So it will become 3d1. Now it will go to d orbit. So 3d1. Then so here it will be 3d2 because d can go up to 10. My transition elements would be over. 3d2, 3d3, 3d4. But you see I have written this in red because this is an exceptional case. When you get 3d4, how it would look like? 1, 2, 3, 4 and 4s2 would look like this. What happens? This electron, instead of being in s orbit, comes to this orbit. Here. Comes here. So what I get? 4s1, one electron got removed and I am getting 3d5. So this number has increased by 1 and this number decreased by 2. Why it happens in this manner? Because the energy of this is less compared to here. So always things goes to the lower elevations, lower height. If you throw a ball, it will go to the place where the height is minimum. So same thing happens here. No, so that in 11th we will be studying in detail that why this energy difference is there. Now for the I will just tell you a simple rule. What they say that when this becomes half full or full, then the electron from here jumps here because then this becomes more stable condition. So this is exception. So now here, now electron will come and fill the. So here I will get 4s2 and 3d5. Is it all right? So now I have got 25. 25. So this is 5, up to here is 20. So 26, 27, 28. Now in 29, again the similar problem will come. How 29 will come? 4s2, 3d9. Because up to here is 20. Up to this number is 20. Up to 4s2 is 20. You can check up. 2, 2, 4, 4, 6, 10, 12, 18, 20. So now instead of 3d10, it will become 3d9 because there are 29. But what will happen now? This will become 4s1 and this will become 3d10. So this is also an exception. And here it will become normal. It will become 4s2, 3d10. So this is how you can make electronic configuration of elements up to 30. So you should be able to write this correctly. For writing this, I have given you this hint. This should be in the rough work. First orbit 2, second orbit S is 2, P is 6, third orbit S is 2, P is 6, 8, then fourth orbit S is 2 and then third orbit gets filled up 3d10. It's very simple. Is it all right? Then one small topic I will cover that also. You will say the comparison between alkali metals means group 1A and halogens means 17th group 17. So you know these elements, lithium, sodium, potassium. You can have a look in your periodic table and see. Is it all right? So these are the elements. So what is the valency of all this? All the sign group 1. So valency is +1. Metallic means +1. It will donate 1 electron. And halogens would be valency would be -1 because it has got 7 valency electron. This has got only 1 valency electron. Now what is the physical state? Alkali metals are shining white soft solid. They are so soft that it can be cut with a knife. But when they are exposed to it becomes dull as it forms oxide. What are halogens? They are diatomic. Means Single atom of fluorine, chlorine does not exist. It exists in the form of two atoms together and becomes a molecule. Now you see here properties gradually changing. Fluorine is highly reactive yellow gas. So fluorine is a gas, chlorine is also a gas, but bromine is volatile red brown liquid. So bromine is liquid and iodine is dark grey crystalline solid. So gradually gas gets converted, gas gets changed to solid. Then conductivity. You know metals are good conductors of heat and electricity, whereas halogens are bad conductors of heat and electricity. Reducing oxidizing agent. You know alkalis lose electron, so they are strong reducing agent, and they gain electrons, so they are strong oxidizing agent. Atomic size. Alkali metals are in group number 1. Then as we move along the period, what we find that because due to more nuclear charge, the electrons are attracted towards the nucleus, the size becomes small, therefore their size is largest because they are in the beginning of the periodic table, except inert gases. Because in case of inert gases, they have got complete shell, so electrons repel one another and the size increases. So halogens, they have got smallest because they are in the end, last 17th group. So the size goes on decreasing, so here it is minimum. Ionization energy. We have discussed that the ionization energy is lowest and it decreases as we go down the group because metallic property increases. So ionization means how easy you can lose the electron. So they can very easily lose, but they are opposite. So they have got high ionization energy and non-metallic property decreases, therefore it decreases down the group. Here also, because here also metallic property is increasing down the group, here also metallic properties. So in the beginning, this is having lowest, this is having high, this will gradually reduce, this will also gradually reduce. Because metallic properties reduces down the group. Okay. Except this noble gases. Then electron affinity, as I told you, all these things are always same. So these things are always same. The reasons are same because metallic properties goes on increasing down the group for metals, for alkali metals, and for halogens it decreases down the group. Non-metallic property decreases, metallic property increases. Now reactivity metals, they are increasing down the group. Here reactive non-metals will decrease down the group. Non-metallic properties decreases. Now reaction with hydrogen. Now hydrogen has got one electron in the outermost orbit and they have got one electron in the valence shell. So they donate one electron to hydrogen, so it is forming ionic bond. We will be learning this in the next chapter. If one atom donates one electron and other accepts, then the atom which donates becomes positive ion and the atom which accepts becomes negative ion, and due to electrostatic force of attraction they remain together, that is called ionic bond. So here they are sharing, like with fluorine, chlorine, bromine, all are sharing one electron with hydrogen. Hydrogen donates one, fluorine donates one, and that pair shares the electron. So they form electrovalent compounds, they form covalent hydrides. So they are forming hydrides with covalent bond, like CCl4, PCl3. So phosphorus is giving 1 to each chlorine atom, and chlorine is also giving 1. So they are sharing. So it is sharing of electrons forms covalent bond. So this is the comparison between alkali metals and halogens. I hope you have understood this. Now one more small point. They say that if we have an atom and a cation, suppose there is a cation, there is an ion, and there is atom. If atom forms a cation, then whose side would be bigger? Or if an atom forms an anion, then whose side would be bigger? See, atom is neutral in charge. You take a case of sodium. Sodium atom is neutral in charge. When it donates one electron, it will form a cation. So now it has given one electron, so it is having now one electron less compared to number of protons. Sodium, you know, atomic number is 11. You can look at the periodic table. Sodium atomic number is 11. So sodium is having 11 protons and 11 electrons. Now, once it donates one electron, it will have 11 protons and 10 electrons. So in short, I can say now my attraction force will be more, so size will become less. So always cations are smaller in size compared to atom. Now to take a case of chlorine, its atomic number is 17. So it got 17 protons, 17 electrons. So 17 protons, 17 electrons. Now, once it accepts an electron, to complete its last orbit, it will become 18 electrons. So when this will become 18, this is 17. So what will happen? So these protons will not be able to attract all 18 electrons